Good morning. Today we are going to see the issues in designing routing protocol for ad hoc wireless networks. The following are the main issues that need to be addressed while designing a MAC protocol for an ad hoc wireless network. Bandwidth efficiency. Since the radio spectrum is limited, the bandwidth is available for communication is very limited. The MAC protocol must be designed in such a way that the scarce bandwidth is utilized in an efficient manner. The control overhead involved must be kept as minimal as possible. Bandwidth efficiency can be defined as the ratio of the bandwidth used for actual data transmission to the total available bandwidth. The MAC protocol must try to maximize the bandwidth efficiency. Quality of service support. Due to the inherent nature of the ad hoc wireless network, where nodes are usually mobile most of the time, providing quality of service support to data sessions in such networks is very difficult. Bandwidth reservation made at one point of time may become invalid once the node moves out of the region where the reservation was made. QoS support is essential for supporting time-critical traffic sessions such as in military communications. MAC protocol for ad hoc wireless network that are to be used in such real-time applications must have some kind of resource reservation mechanism that takes into consideration the nature of the wireless channel and the mobility of nodes. Synchronization. The MAC protocol must take into consideration the synchronization between nodes in the network. Synchronization is very important for bandwidth reservations by nodes. Exchange of control packet may be required for achieving time synchronization among nodes. The control packets must not consume too much of network bandwidth. Hidden and exposed terminal problems. The hidden and exposed terminal problems are unique to wireless networks. The hidden terminal problem refers to the collision of packets at a receiving node due to simultaneous transmission of those nodes that are not within the direct transmission range of the sender, but are within the not within the direct transmission range of the sender, but are within the transmission range of the receiver. Collision occurs when both nodes transmit packets at the same time without knowing about the transmission of each other. For example, consider figure 6.1. Here, if both node S1 and S2 transmit to node R1 at the same time, their packets collide at node R1. This is because both nodes S1 and S2 are hidden from each other as they are not within the direct transmission range of each other and hence do not know about the presence of each other. The exposed terminal problem refers to the inability of a node which is blocked due to transmission by a nearby transmitting node to transmit to another node. Here, if the transmission from node S1 to another node R1 is already in progress, node S3 cannot transmit to node R2 as it concludes that its neighbor node S1 is in transmitting mode and hence it should not interfere with an ongoing transmission. The hidden exposed terminal problem significantly reduces the throughput of a network when the traffic load is high. It is therefore desirable that the MAC protocol be free from the hidden and exposed terminal problems. An error-prone shared broadcast channel. Another important factor in the design of the MAC protocol is the broadcast nature of the radio channel, that is, transmissions made by a node are received by all nodes within its direct transmission range. When a node is receiving data, no other node in its neighborhood apart from the sender should transmit. A node should get access to the shared medium only when its transmission do not affect any ongoing session. Since multiple nodes may contend for the channel simultaneously, possibility of packet collisions is quite high in wireless networks. The MAC protocol should grant channel access to nodes in such a manner that collisions are minimized. Also, the protocol should ensure that all nodes are treated fairly with respect to bandwidth allocation. distributed nature or lack of central coordination. Ad hoc wireless networks do not have centralized coordinators. In cellular networks, for example, the base stations act as central coordinating nodes and allocate bandwidth to the mobile terminals. But this is not possible in an ad hoc network where nodes keep moving continuously. Therefore, nodes must be scheduled in a distributed fashion for gaining access to the channel. This may require exchange of control information. The MAC protocol must make sure that the additional overhead in terms of bandwidth consumption incurred due to this control information exchange is not very high. And mobility of nodes. This is very important factor affecting the performance of the protocol. Nodes in an ad hoc wireless network are mobile most of the time. The bandwidth reservations made or control information exchanged may end up being of no use if the node mobility is very high. The MAC protocol obviously has no role to play in influencing the mobility of the nodes. The protocol design must take this mobility factor into consideration so that the performance of the system is not significantly affected due to node mobility. And design goals of the MAC protocol for ad hoc wireless networks. The following are the important rules to be met while designing a medium access control protocol for ad hoc wireless networks. The operation of the protocol should be distributed. The protocol should provide QoS support for real-time traffic. The access delay refers to the average delay experienced by any packet to get transmitted must be kept low. The available bandwidth must be utilized efficiently. The protocol should ensure fair allocation of bandwidth to nodes. Control overhead must be kept as low as possible. The protocol should minimize the effects of hidden and exposed terminal problems. The protocol must be scalable to large networks. It should have power control mechanisms in order to efficiently manage energy consumption of the nodes. The protocol should have mechanisms to adapt for adaptive data rate control. It should try to use directional antennas which can provide advantages such as reduced interference, increased spectrum reuse, and reduced power consumption. Since synchronization among nodes is very important for bandwidth reservations, the protocol should provide time synchronization among nodes. Thank you.